Hello, everybody. Welcome to another episode of Transfigured. I am here with Dr. Jim. Dr. Jim is sort of a resident member of this little corner of the internet. We've interacted some before, and you've been in videos with Paul Vanderklay and other sorts of people. He reached out to me after seeing some of my conversations with Vervaeke or Paul Anleitner related to AI and healthcare. And as you can probably guess already, he's a doctor himself. So, Dr. Jim, do you want to talk a little bit about maybe your background and sort of your current practice and stuff like that, and how that relates to your interest in these topics?
Sure. I'm a cardiologist, and I'm a presently practicing cardiologist. I've been in practice for many years, 30 years almost now. And I came from a background of more technical stuff. I actually got a degree in physics, actually, an undergraduate degree in physics. And so I had an interest in math and, kind of the thinking around physics and all that kind of stuff. Loved the, wave particle duality stuff. It was all into that when I was younger. And that kind of gave me a different kind of way into medicine. And in fact, chose to do cardiology partly because of the toys in cardiology, meaning the technology that's associated with technology, imaging technology, and that kind of stuff. So I had that kind of interest to start with. And then as I got into practice, and wasn't nervous or shy about that as compared to a lot of my colleagues. A lot of people in medicine, particularly in the generation that I trained in, really were not into software, computers, all that stuff. So the whole daunting task of becoming computerized was both not very comfortable for most of my colleagues, but also very much my thing with my kind of geeky background. And so that led me to be one in my practice that kind of took that on, became the liaison, let's say, between the technical side of the information technology and the clinical side of that. And I still play that role in my practice. So, and then of course we've had this, I would consider it reasonable to call it a revolution in medicine over the last 15 to 20 years of the adoption of information technology to medicine. I think 20 years ago we would have said, or 15 years ago we would have said, medicine is clearly behind the rest of the culture in terms of adopting the information technology in particular, and what is referred to as electronic medical records. I think that has changed dramatically, and it's been a very significant evolution that has been kind of accelerated. And I think now it's the case that medicine is probably not behind anymore in that. Mm-hmm. And I've been kind of integral in the process of, kind of vendor selection, all the way from the first point of vendor selection of these systems, all the way to the implementation and deployment, and then maintenance and modification of these systems, at least in my little world here in this practice. And it's not a small practice. It's a fairly large hospital system, multiple 5-6 hospitals in this system. So it's not small practice. So we have all the experience of how that all happens and the complexities of that, et cetera. And then very recently, of course, as the AI craze has, kind of burst upon the world, everybody wants into it. And the electronic medical records also want in on that. And they want to kind of test the question of how it could be used appropriately and deploy it, in fact. And we're in the process of testing and trying to use these kinds of systems within our program today. So I have that kind of experience with it. And I would say that colors my opinions about this and the way I'm going to frame this. But I guess that's a good enough introduction to start with.
Yeah. And just to talk a little bit about my own personal career. So right at like sort of the very end of George W. Bush's presidency, I think he might have even been a lame duck at this point. Barack Obama might have been already elected as the successor. He passed what's called the High Tech Act, which sort of mandated that hospitals get these electronic medical records, and also threw a huge ton of money at in forms of carrots and sticks in terms of helping hospitals adopt these things. So when I graduated undergrad in 2011, I went to work for Epic, which was the largest medical record company at the time. I think has only even its market share, I think, is even higher than it was back then. I didn't really.
Just to let you know, Epic is the program that we use.
Right. So, and maybe you're a physician champion. I won't use too much inside baseball language, but it's funny because when I first started working at Epic, I didn't really know what I wanted to do when I was graduating undergrad. It just sort of happened to be the best job offer and most exciting opportunity. 2011, when I was graduating, it was still kind of in the recession, still kind of coming out of the 2008 financial crisis. And so opportunities weren't as high as otherwise. And because of this High Tech Act, there was a ton of money in the hospital IT world. And so that's sort of where I ended up. I worked in Madison. And so I spent a lot of time.
You were in Verona, huh?
I was in Verona, yeah, although I lived downtown with other cool kids.
Okay.
It was a pretty fun gig as a 22-year-old. It felt like you were living in college, but like getting, instead of paying money, you were getting paid. And so you had a little bit more cash in your bank account for the weekends than the students did. And so it was a pretty fun time. And I also met my wife while I was in Madison.
Oh, is that right? Yeah.
Yeah, so that was a pretty fun stage of life. But I would be one of those fresh 22, 23-year-old kids in the hospital when you guys were turning on Epic for the first time, helping all the older doctors, know where to click, know what to do, help navigate this transition. And there was a lot of resistance, and getting yelled at or getting angry, and all those sorts of things. I remember all of that very fondly.
Not really understanding what they were talking about when they were being angry.
Yeah. And I'm like, I just got trained on this thing like 2 months ago myself. I'm doing my best. So that set me really on my career trajectory, where I've sort of developed my interest in machine learning and statistics and artificial intelligence, and having this health IT background. So I'm sure there's a lot that we could talk about. That's just sort of the details of that. But we can also, talk about AI more generally. And we have this huge shared vocabulary of healthcare IT, and then also this sort of shared conceptual framework of this little corner of the internet, like in Paul Vanderklay, Johann Vervaeke, and those sorts of folks. So I'm interested to see where this conversation goes. So what do you want to talk about from there?
Yeah, lots. But let me just try to say some very general things to try to start us off. Let's say, number one, I would say that I'm going to be a little bit. Well, I'm going to lean on the side of not being as concerned about the dangers of this stuff as compared to the general conversation. So that's going to be kind of a gist of this. That does not mean that I don't understand the risks in this technology, and that it's very reasonable to be talking about those risks. And in fact, just to kind of half contradict what I just said, I anticipate that we will make the mistakes that are inherently available to us to make. And so that sense of optimism about it is kind of in the context of understanding the general reality of human weakness. And that is very likely to play itself out in this arena, just like it has in every other arena. But ultimately, I think the solutions to this are the same solutions that we apply in other arenas. And that leads me to say something that I think is a little contradictory to what I feel Vervaeke says, and that is that I'm uncertain about the categorical distinction between what we're referring to as artificial intelligence and any other kind of technological domain that humanity has grappled with. And I kind of think that it's actually not this, essentially different, and therefore the way we would approach it is kind of the same as we have other things. And the only other second thing I would say, and here I'm going to sound like I'm a detractor of John Vervaeke. To some degree, I think I do want to push back on him, but if you listen to him, he's very complicated and nuanced about the way he talks. So I really don't think I'm that far away from what he may be saying in essence. But the second thing I would say as a resistance to the way he talks about it is that I think it's probably going to be a mistake to assign too much sense of agency to whatever we regard this technology to be. And that in fact, I think we should take a different stance on it and regard it as something that's well within our abilities and capabilities to be the master of, to control, and that in fact that's an important posture that we should take as we move forward. And the language of John's that tends to kind of speak of the technology or whatever we're talking about when we're talking about AI as having its own personhood or having its own independent agency is both, I think, not probably right and probably ill-advised.
Yeah. I think that I mostly agree with you from what I can tell from the short and maybe even medium term. It could be the case that decades from now, things have morphed into something else. But at least the way that I see AI being used in healthcare now, although I should say I'm not technically in healthcare anymore. At my current job at Google, I'm sort of outside of healthcare, but I pay attention to those things. It wasn't that long ago that I was very involved with this stuff. Just like 2 years ago, I was still at a hospital. So I generally think that you're right, that at the most part now, AI or machine learning or predictive modeling and stuff like that is very much within the realm of a tool. And it's really not that different categorically from things that we've seen before. Like there are in various realms of medicine, there have long been things that have been called, scores or risk scores, where a physician would ask a series of questions and give a couple numeric answers to say 5 or 10 questions. And then you do a little bit of math based off of those questions. And then you get a risk score for the patient. I'm sure cardiology has some of those sorts of things. And you could do that with pen and paper even before computers were around. And it's actually not that fundamentally different from how the AI models work now. Maybe it's fewer variables and the math is a little simpler, but the idea that there are input variables that get turned into numbers, a little bit of multiplication and math in the background, and then you get one number and that helps you make medical decisions. That's actually pretty old already.
Yeah, and I would say that, that raises the question really that as another question that I have, and maybe you can just kind of talk a little bit about this after I ask this question, and that is, what is it that we're actually referring to when we say artificial intelligence? And I think that I'm uncertain about that. And people, it's a natural way that we use categories, so I'm not going to be overly critical here because we definitely need to talk about something and we need to throw a name out there and then start talking. And when we do that, we tend not to turn back to the category and spend a lot of time talking about what it is that we're meaning, what are the criteria for what we're talking about. But I still think that when we talk about artificial intelligence, I don't know that it's the artificiality that we're really referring to. So that seems to be a misnomer. I think it's the autonomy that we're really talking about. If you wanted to focus your attention on something about this category that we're trying to point to, it's the autonomy or the independent action of it. And then the intelligence part of it, and here John is so good at these kind of fine distinctions between, rationality, intelligence, wisdom, that kind of distinction. And I'm not able to kind of make those distinctions as well as he does, but I'm not sure that intelligence narrows the field very much either. And so when I think we talk about artificial intelligence, we kind of think we're probably referring to something like the large language model, or we're kind of thinking we're talking about decision support, which is kind of what you were just talking about, algorithms for decision support, or the generation of, I don't know what you call these parts of it that try to generate their own code. There's probably a name for that I'm not familiar with, but that would be another kind of big division there. And we're kind of putting those things in a bag and calling it artificial intelligence. Or do you want to speak to what is?
Sure.
What it is we're to?
I think that there are maybe a couple different categories that I've seen in healthcare that I think are helpful for thinking about this. Like, what we're not talking about is we're not just talking about any sort of way that a computer or technology can help with medicine or any other thing. Like when you write a doctor's note for a patient and save it in a word processor, and then the next time you see that patient, you can click a couple buttons and see your note that you wrote from last time. That's not what we're talking about. When I feel like there are maybe kind of a couple different gradations of artificial intelligence or predictive modeling that I've seen in healthcare. Some of it is just, a lot of it is risk scoring for decision support that you mentioned. And like I said, there were even paper versions of this before there were computer versions. And really the computer versions are often just have more, like you take some variables about a patient, turn them into some kind of number, run them through math, and then that math turns it into one number. And then that one number is like a risk score or a complexity number. And then if the number is above a certain threshold, that might guide your course of treatment in a certain direction. If it's below a certain threshold, you might go in a different course of treatment. And somehow capturing, danger or risk or likelihood of a certain kind of outcome. Because if you're doing that with 5 variables and a little bit of addition and multiplication, that's not that different from doing it with 100 variables and super complex linear algebra that's happening behind the scenes with, a really fancy predictive risk model. So that's one sort of thing that is this very kind of like trying to capture patterns in patients through math that help guide decision-making by presenting some sort of risk score or number to the physician afterwards. And even then, there is still this, there are clinical guidelines, right? Like if the patient score is over here, probably do this. If it's in the middle, do this. If it's on the low end, maybe do this. But at the end of the day, the physician always still has judgment over that. There are clinical guidelines and stuff like that. And those sorts of things can be updated and changed. But at the end of the day, it's helping inform decision or physician care. Yeah. And then so that's one sort of thing that I've seen. And like I've already mentioned this a couple of times, that even predates computers. And then there's sort of another extra category, where I'll see the machines actively making the decision. And this is what I would say is the difference between predictive modeling and prescriptive modeling. And I've only seen a couple projects that do the prescriptive modeling. It is also more legally complicated. And in addition to being more technologically complicated, where the computer algorithm is in fact making a decision, say, about which medication to give a patient or something like that. Almost always there still needs to be that last final click by a physician or something like that, so that there is medical responsibility in the hands of a licensed professional. And sometimes there often needs to be patient consent, like it could be part of a clinical trial. And so the patient is consenting to participate in this clinical trial where a machine is going to decide which medicine to give them. And then the doctor is the one who finally clicks the order on that. But that is an extra level of thing, but it's not that different from the first thing, because it's often taking input variables, crunching it in, and saying, I predict that this medication will work of the 3 options the best, and so I'm going to give this to you. And then oftentimes there is some sort of follow-up on that patient. Did the medication work? Did the outcome for that patient prove positive or negative? And then there's this extra category. So we've got predictive modeling, prescriptive modeling, and now there's this generative AI. And generative AI often takes a prescriptive model and then generates a whole bunch of stuff from it. And that often right now it's text, but it could be images or stuff like that. Like when people have been playing with these, like ChatGPT is a text generation generative model. There are those picture generating models like I'm forgetting their names, but Google had their recent fiasco with that and all that sort of thing. And that sort of, but that I don't see a ton of applications for that on the front line of healthcare, but I see a lot of that on the back end. Like maybe if I could take your quick shorthand from your visit and turn it into a full-fledged doctor's note, or maybe if I can take all the documentation from your patient and turn it into the bill that we send to the insurance company that has all of the coding marked up on it, that would be a really helpful thing. But I don't see a lot of that, like in terms of facing the patient. But one thing that'll start to get interesting
might be more than you think.
Is can I start to use ChatGPT or Gemini or what have you to ask it medical advice? And then it's generating text, but this text is based off of medical textbooks and scientific research and electronic medical records. All it's doing is predicting text, but the text that is predicting is medical advice. And so that'll start to get way more interesting. So anyway, I'll pass it back to you. But I view each of those things as somewhat discrete categories that are all being lumped under artificial intelligence.
Yeah, I think that's a good outline. I think it's a very good outline. I'm going to push a little bit differently than you, because I do think this third one you talked about, where it's generating kind of text, is probably going to be a little bit more integral. Although it's going to be on the back end, like you said, it's not going to be in the front end of the patient interaction and decision making. It's going to be on the documentation and the billing, maybe educational material for the patient, that kind of stuff. But I think it'll be a little more elaborate than you're describing there. But I want to throw out an example here that I think can fortify or kind of defend my take that I'm not sure that artificial intelligence is either, distinctly different than other technological experiences that we've had. And also that a lot of this, which you've said already, a lot of this stuff that we think of as AI now is not really as new as people think it is. And the example that I'm going to use is a piece of technology that I use, that the hospitals use all the time, and that's an EKG machine. And I'll explain that in more detail in a minute, but I want to give a bigger outline of the ways in which I think I would want to think about technology in general, so that we could kind of have a framework for thinking about, what is technology? And I have kind of four kind of models, or four kind of ways of viewing technology that I don't know if we'll have the time to kind of review them, but one is a kind of reductive materialistic model. And that's, I think, the one that we inherit, and the one that a lot of this corner of the internet is pushing back on. But nonetheless, I think there's some useful information in thinking about technology in that way. Then I would move up to the next level, which is what I would call the spiritual kind of view of technology. And that's the one I think that Jonathan Pageau is kind of forefronting. And he used the example in the conversation with Ken Lowry of the Sorcerer's Apprentice. And I would kind of frame that way, and I'll have a little more to say about that if we get to that. The third way I would think about it is the way that John Vervaeke talks about it, and I would call that the embodied model of technology. And it's the one I'm kind of tending to be a little nervous about and would want to push back on. And then the fourth one is a kind of maybe a stretch in terms of the description, but I would refer to it as an icon model of technology, in the way that technology would fit into a community that surrounds it, and therefore gives its meaning through if you will, sacred attention in the community to the icon at the center of that. But let me I don't know how much you want me to kind of riff on that.
Yeah,
but
sure. Yeah, go in and define those a little bit more carefully, and how you think how that'll affect how AI gets interpreted or used.
Right. So the materialistic model, I use a very simple example for this, and that's a door latch. So a door latch, and the reason I would use a door latch is, number one, it's simple, and number two, it's probably prehistoric. We probably are using door latches, basically once we started making, housing or abodes.
Mm-hmm.
And if you think about what a door latch is it's an extension of our intent into the world. It's my intent is to hold the door closed against the weather, and I don't want to stand at the door all the time. So I'm going to put that intent, I'm going to kind of manifest that intent in this material object, the latch, and that allows me to leave the latch out there in the world and go on about my business, understanding that the latch is going to kind of embody my intent and keep the door closed. And you can see that in that last sentence. This is kind of an Aristotelian model, I think. In that last sentence, it's going to keep the door closed. That kind of language is kind of attributing to the latch some sort of ability or some sort of action or some sort of, but it really is a material, inert object.
Mm-hmm.
And in fact, I think in this modernist view, we end up with this kind of Descartes-like split between us with intent and the world as inert, because in order for the latch to work as a latch, it needs to be inert. It needs to be, it needs to be submissive to my intent. It needs to stay the way I make it in order for it to function as a latch. Mm-hmm. And so we've now divided the world up between us, which is the repository of intent and action. We have goals. We have, the ability to manipulate the world. We have power to manipulate the world. We can make a latch, and the latch then represents the embodiment of that in the physical. And it needs to have that countervailing or contradictory, or it needs to be different than me. It needs to be other than me in the sense that it doesn't have its own intent. It doesn't have its own animation. It doesn't have its own ability to act other than the way I configure it. Now, if you think about that a little bit, you can realize that we might start talking in a direction towards John's notion of imputing on these things, things like wisdom. So if you, keeping the door closed against the weather, well, that's a goal. Of course, we're leading to a higher goal, always pointing to the highest of goals, but nonetheless, there is a goal embodied in the latch. And if we think about something a little bit more poignant or a little bit more important, we realize that if we put the latch too low to the ground, our children can open the door, perhaps get themselves into harm. So we make the design decision essentially, to elevate the latch higher so that the child cannot open the door. And therefore, we have imputed upon the latch in its design a sense of a value, a sense of wisdom.
Yeah.
So that's a materialistic model. I don't think it's going to be complete because it doesn't quite have all the detail that I think it needs to, but it does start at least with the notion, a kind of basic understanding of technology. And it has in it this notion of goals, and it has in it this notion of our being the repository of agency and the goal. The spiritual model, I think, is well illustrated in The Sorcerer's Apprentice. I don't know Goethe's poem, but I do know the Disney Fantasia, and it's Fantasia, right?
Yes, I think so. Yeah, I haven't read the poem either, but I have seen Fantasia.
So in that cartoon, in that narrative, there's Mickey Mouse, who's got he's in the sorcerer's shop there, and the sorcerer leaves. And of course, the sorcerer leaves his hat on the table. And I don't know what they're doing in this shop. I can't remember, but there's brooms and there's water and there's buckets. And Mickey puts on the hat, which gives him the power to, kind of activate everything. And in this model, the action is actually out in the world. That is to say, the brooms are able to animate and move around. They're able to do things that seem to be intentional, like bail the water and climb upstairs and stuff like that. So it's a more spiritualized world or enchanted world that we're seeing there. And I think that perhaps is capturing the power of the world over and above us, and perhaps the risk of what might happen if you get this stuff out of control, of course, then Mickey Mouse the whole story is that he gets himself in big trouble by not being able to control these powers. And Pageau mentioned this as a problem in that conversation. I kind of actually envision it actually as having a solution. And the solution, of course, is the sorcerer himself. And the sorcerer returns. The sorcerer has mastery, can control these powers.
All right. And so you were just about to talk about the iconic view as opposed to the sort of inert view or the tool view. And then you have the sorcerer's apprentice view. So what's the iconic view and how does it differ from those previous two?
Yeah, just to finish up on the sorcerer's apprentice, just to make sure I make that last point, and that is that the sorcerer represents the solution to the problem, if you will, and you have a sense of mentorship. You have a sense of inexperience leads to bad outcomes, but experience can be gained, and generational passing on of wisdom is certainly a possibility, and control and mastery comes through that. Moving to the icon version of that, it's really just more of a communal view of the sorcerer's apprentice view. In other words, that the way in which, it's a little harder for me to describe, so I'll give it a try here, but the way in which a technology would fit into a community of people acting with cooperation, charity, and intent towards a higher goal with unity of purpose is something that's done with the icon. Here I'm referring to the technology at the center of it as a sacred object, if you will, at the center of that activity, but the activity is being carried out by the community with its communal integrity and purpose, if you will. Gotcha. And that's actually how I think the technology is in its best form, how technology is actually used by us in our communities of purpose out there in the world right now. And I think ultimately I would support the idea of recognizing that, seeing the ways in which we, in a healthy way and in a positive way, we generate these communities and support and honor those communities and nurture them. And if that turns out to be possible, then that's going to be the way in which these technologies can fit into a community in a fruitful way.
All right. So the three views, if I'm sort of understanding, they're sort of like the tool view of technology, where the world besides human minds is basically inert. And we learn to wield these technologies just like they're inert tools. In the sorcerer's apprentice view, the world out there outside our mind is a little bit more animated and it has a little bit more drive in and of itself. But then you're still trying to learn how to wield the tools. It's just that you use things like sorcery more than you use things like, I don't know, science or tool manipulation. And then
experience.
Or experience and stuff like that. And then in this third view, it's more communal based, and that it's more, I guess, understanding it relationally, maybe perhaps, instead of something simply to be wielded. Am I sort of understanding you correctly?
Yeah, and perhaps even emphasizing a kind of sacred attitude towards the technology in a sense of respect, a sense of respecting the power of the technology, and therefore, kind of configuring our relationship to it in such a way that we don't underestimate the both the power for good and the power for ill.
Sure. So what do you think AI tools in that sort of third, more iconic view look like? What does that sort of integration in that way look like? You could either be specific to medicine or you could branch outside of medicine if you wanted.
Yeah, I think the EKG machine example, and I think it's doable to be straightforward in my description of it so that a non-medical audience will understand what I'm talking about. But I do think it has some features of it that is illustrative of the point that I'm trying to make. An EKG is just a device that takes an analog electrical signal off of the body, and that signal electrically reflects the electrical activity of the heart. And it turns out that the way in which we do this allows for a wealth of information about what's going on with the heart, both in terms of healthy activity, but also abnormalities. And this has been going on since the 20s. A guy named Eindhoven developed this way back at the beginning of the 20th century, and it has been a very rich area of research. People have spent their lives studying this one technology. And just to use a simple example that has a very pointed kind of consequence, and that is the diagnosis of an acute heart attack, or what we refer to as an acute myocardial infarction. And it turns out on the electrical signal, we call it a 12 lead because there's 12 signals that come in. On that EKG, there's a very obvious and clear-cut finding on the EKG that reflects a heart attack in action at that moment. So the way these EKG machines work, initially, of course, they just printed out the analog signal. This would have been in the 50s that you would have had oscilloscope-based EKGs that would print this stuff out. And then it would be all up to the individual physician to interpret that. But fairly soon after that, and well mature into the mid to late 70s, were ways of digitizing those signals and then applying criteria to the signal that would allow the machine to actually recognize the difference between a non-heart attack and a heart attack.
Yeah.
And so what the machines do, and this is a technology that existed when I started my training, which was in the late 80s. So this was mature technology by that time, even before I was doing this. It would spit out a diagnosis. On the piece of paper that would come out of the machine would be the electrical signals, but it would also have some verbiage at the top of it. And that verbiage would be generated through an algorithm, through a program that would detect these findings and then print that out. And of course, if you're sitting in an emergency room and you're a technician doing an EKG, you know, the reading on that EKG is in language. So it's much like this sense that we have about large language models, or is that it's turning a set of criteria from a program into a declaration in language. And that generates a lot of activity. That generates a treatment protocol for that patient that is basically coming from the machine, if you will. And so that raises, certainly as a first approximation, raises all the concerns that you were potentially talking about with machines actually proscribing things.
Right.
But it turns out that's not the way we use the EKG. The way we use the EKG is that represents just the moment of recognition, and there's a whole community of people that are surrounding this that actually turn that diagnosis into a wealth of activity, including checks and balances that are geared towards correcting for incorrect declarations by the machine.
Right.
Johann Wolfgang talks about hallucinations or lying. Well, certainly EKG algorithm will declare a heart attack in somebody who's not having a heart attack. That will happen.
Right.
It's not only that it happens, we know it happens at a certain percentage of the time. And it'll also miss heart attacks. It'll not say there's a heart attack happening when there is. And so we recognize that. And so there's all sorts of checks and balances that surround that. And so in the end, the EKG machine, even though it's making this kind of very affirmative declaration, is doing so in the context of that larger community that's surrounding the patient. And when I say that, I'm talking about here a community in one moment in the emergency room, let's say, and we've got technicians and nurses and cath lab people and cardiologists and ER docs, and all these people are surrounding this. But really, it also includes the temporal community, meaning the history of this and the history of the management of heart attack and the way in which guidelines are developed and the larger community in national societies and the way those national societies fit into a world community of cardiology. And so we have this whole complex thing that is surrounding that one technology, which certainly has some of the flavor of the concerns that people have about AI, but it's really embedded deep into that community and its attempt to surround that with best practices.
That's interesting. A thing that makes me think about is the speed at which things are changing now, causing problems sort of in and of itself. So you have this EKG machine, and it will tell you whether or not the patient has a heart attack according to its algorithm. But it's also sort of giving you the raw information with which it's making that determination, so that it can be supplemented by human judgment. All right. So let's imagine that you're some tech company who wants to update that algorithm in the EKG machine. And they're like, that algorithm that's in that old EKG machine, it's from the 80s or whatever, it maybe only has a dozen different mathematical calculations that it's making to determine whether or not to assign heart attack or not heart attack to that EKG output reading. Let's imagine I'm going to try and outcompete my competitor, and I'm going to put 10,000 mathematical calculations in the EKG machine to try and reduce the false positives and reduce the false negatives and be more mathematically precise with this. Well, then suddenly that changes the way that doctors who have been trained and the whole medical community staff around that. And that's just like one easy example. Now, it's not just that we're tweaking old algorithms, we're adding all these new algorithms. And it seems like it's sort of, that's almost a challenge in and of itself to figure out ways of updating changes to old friends and incorporating new friends within this whole medical decision-making process.
Yeah, and this goes to your example of the mammograms. And well, first off, I would say that it already is the case that these algorithms are updated because there's, for just clinical reasons and the fact that these companies are integrated into these societies, they don't live independent of the societies that talk about and research and iterate these algorithms. But it's also the case that there's competition. So at least in a kind of a capitalist environment in which there are different vendors who are trying to out compete their competition, we get some help from that probably. But I think a more interesting one is the one that you were talking about with the mammograms, and that is that we would, in a certain sense, go away from any algorithm and rather iterate the result based on some sort of a machine learning model, where you just say, all right, I don't care what you see on the analog signal. Just go ahead and say what you want. Here I'm talking to the algorithm. Say what you want about it, but then I'm going to feed back the fact that that person did or did not actually have a heart attack in the end of the day. And then you're going to get better at recognizing a heart attack independent of whatever algorithm you get to choose. Here again, I'm talking to the algorithm itself. You get to choose whatever it is that you see in the EKG or see in these signals. You get to decide which ones worked, but you're gonna be constrained by me coming back to you and saying, yes, this was a heart attack. No, that was not. And we're gonna keep doing that over and over again until we're satisfied with its results. So this was how the chest playing programs, the more advanced versions of the chest playing programs worked, and the Go programs, I believe, were similar, in which they just let the thing play and its own decisions about what moves to make, and it ultimately, quote unquote, learned. Now you're going to probably come up with similar criteria in the EKG, but that is I wouldn't say, maybe it's more than a subtle difference in terms of how these algorithms would be generated, is to give it to the algorithm in a machine learning sense to make these decisions. But I would say that wouldn't change the fact that the output would still be embedded in this community with all of the wealth of the ways in which we backstop that, including research. Because what would happen is the algorithm would be developed and then it would be plugged into a randomized controlled trial and compared to the pre-existing algorithm, and you'd get all the statistics about all that, and you'd say, this is a little bit better. And then you would judge using it on that. You wouldn't just let it do its thing and then say, well, I guess it's telling me this. I just have to bow down to it. No, we don't really do that.
That brings up the whole topic of explainability in machine learning. I know that a lot of people have been talking about, oh, well, if we're going to integrate these models, and I was part of projects like this at hospitals where we need to help, people or the physician or the caretaker understand why the machine learning algorithm is making the recommendation that it is. It's like, it has no idea. That's not how these things work. It is just some weird, obtuse mathematical calculation, and it has no idea. It has no ability to give you a reason why. And that's sort of like when you go back to sort of those simple scoring methods where you take a couple variables. What's the patient's pulse? What's their blood pressure? Do they have a history of this condition, this condition, this condition?
How old are they?
How old are they? Right. And then you kind of do the math yourself. It's very transparent what's going on. And I can be like, oh, this patient got a high score because their dad had their dad had a heart attack and their blood pressure is really high and they're elderly, right? Okay, so now I understand that. But the more complex the math gets behind the scenes, the less clear it is how to attribute any particular variable to the output, because the mathematical relationship gets more and more complicated to explain. Even, I would say, even past a point of actually there being a simple explanation. It's like, well, I could tell you the mathematical formula, but that doesn't mean anything to us. And so it is just simply giving a risk and giving math. But I see this kind of split emerging between verbalized reasons for what's happening and mathematical output. And we sort of think that there should be a connection between them, but they actually are separate things, and that it gets harder and harder to integrate it into a human machine partnership the more mathematically obtuse and obscure and complicated these algorithms get.
Entirely. I think that if you look at the way in which risk scores, let's just take as an example, or scoring systems like you're talking about are actually used, they always get a little bit of a splash when they come out. There'll be a research trial that shows that this risk score is superior to what we've been doing, and people will be talking about it, and they'll say, oh, we got to use this, and then there'll be a kind of a little bit of a push initially, like we should marry ourselves to this. We should subject ourselves to this risk score, Yes, and everyone's talking about that. You have the little laminated cards that you carry around to look at the risk score. And then ultimately those risk scores drop in their priority, because ultimately they're for the most part telling you what you already knew.
Yes.
And they end up being a good kind of setting of the landscape. It's making sure you're not off the farm,
Yeah.
It's making sure you're in a good area here, that you're maybe updating yourself with new research a little bit, maybe making sure that you're not kind of wandering astray of the standard, or wandering astray of what has just generally been accepted to be good practice. They function that way, but they end up being like third down on the priority list of how you make these decisions.
Yeah.
And they can be very useful, but they're only useful at that level, really.
Right. And it's almost as if the process of going through and generating the score was sort of helpful in and of itself, almost like it's like a medical checklist, that going through and asking the patient about this and having the doctor think through these different categories gets that in their mind. And that's almost as helpful as whatever number comes out the back end itself.
Absolutely. And a lot of these are generated through a kind of machine learning kind of thing before machine learning was a thing, in the form of which you are aware of, this statistical technique of the multivariate analysis.
Yeah.
You can do multivariate analysis and put in variables that you have no real idea might be related, and yet it pops up, it ends up being a more impactful variable than you anticipated. And so that gives you well, wait a minute, why is it that, this variable actually seemed to predict some risk there, and it leads you to think through the problem, and we learn in that way. And that's the way the machine can teach us a little bit. That is to say, the machine of a large multivariate analysis can actually inform us to rethink the problem, and that's gone on iteratively through the history of medicine.
Yeah, and another thing that I think is interesting, like I would say one of the most fruitless projects that I was ever a part of was trying to make a algorithm during COVID that was trying to predict whether a COVID patient should be admitted or not. And so we trained this algorithm based off of the history of COVID patients and whether or not they got admitted based off of variables. But all that we're doing is trying to predict the decisions that the doctors have already made in the past.
Yeah.
And so then it's like, say, 80 or 90% accurate or something like that. And then we present a number to the doctor that we're like, here, we think you're going to admit this patient, or we think you're not going to admit this patient. But all we're doing is a mathematical approximation of what the doctors were already doing. And so it's like, what?
Well, I would say I wouldn't be quite so. I would say that work you were doing, it fits into a larger project that was beyond that. But that work you were doing is not.
Uh-oh. Oh no.
Yeah, I would talk about the kind of program you were on, and I know you were frustrated with your experience with it, but it does fit into a larger project that is an ongoing useful thing. I mean, I think we have learned, just outside the setting of COVID, just the notion of how do we manage community acquired pneumonia in the emergency room setting is a long history of probably less than stellar performance in the past in taking care of patients who present with pneumonia, and some understanding through statistical modeling like you're talking about that there are actual criteria that we can use to do certain things. For example, there was a recognition that if certain criteria were met, that patients benefit from IV antibiotics. And it turned out that people weren't really clear about that, or they knew that, but they didn't really see it as a very much of a priority, let's say. And here I'm talking 20 years ago or something. And then some research was done in the kind of form you're talking about that asked the question, would people benefit from a strict administration of IV antibiotics in 1 hour, within 1 hour of presentation, or not? And the reason that's important is that would mean that the antibiotics needed to be administered in the emergency room. Mm-hmm. And the delays that were happening were that people would say, the ER doc would say, yeah, you got pneumonia, you need to be admitted. And then the whole admission process would happen, and the patient would end up on the floor, and it would take time to do that. And ultimately, they'd get their antibiotics 3 hours, 4 hours later. Mm-hmm. And ultimately, statistical studies like you were talking about, different ones than yours, but still very much like what you're talking about, led to a recognition that, yes, it is beneficial to give that antibiotic in the emergency room. And over the last 15 years or so, that maybe a little longer, has changed practice. There are metrics for getting those antibiotics into patients within 1 hour of arrival. That means it has to happen in the emergency room. That means pharmacy needs to be involved. There's a whole complex set of things that come out of that in terms of behaviors and trying to meet guidelines and metrics. And it comes from that kind of project that you were part of. Even though yours was frustrating, that kind of project can lead to improvements.
Yeah. I think go ahead, Dr. Jim.
Now, because I've heard you talk about this in the way that you do, and I heard your conversation with Vervaeke, with John. I feel like you are, well, I'd like you to describe, what do you think about what John is saying in terms of the way I've characterized it, and how do you feel like this notion that I have expressed, which is that I think he's going a little bit too far in using language that appears to attribute agency to these systems, and that is in and of itself for me something that we should perhaps be reluctant to do. And I don't know how you feel about that, but that's my take on it.
I generally agree. I think that there isn't quite a there in them yet, in terms of them being some sort of conscious being, certainly not, or having even sort of comprehension, or even like agency. When a model is making a prescriptive recommendation and then that happens, that's getting something closer to agency, because it's having an actual effect on the world. But that is, I still don't think, quite the full level of agency that we mean when we talk about a human having agency.
Yeah, and that is an interesting tension between, let's say, Paul Vanderklay's conversation with Vervaeke, because he's wanting to have a conversation with Vervaeke about angels and demons and trying to get John to say something that I think he's actually saying about AI, and that is that he's seeing them as spirits, or he's seeing them as embodied agents, or he's getting close to that. And that's exactly what I think Paul is trying to kind of start a conversation with him about. So I find that'll be a little bit, stepping a little bit away from medicine as the center of our conversation. It's a little bit more in that realm of how do we deal with the notion of egregores, or a notion of
higher level beings or something.
Level beings. Exactly.
And I don't think that is super helpful, at least not yet, for the healthcare thing. And I actually think that there is kind of a danger that I see of people who maybe over attribute to these things something more like personhood than is really deserved. And the specific danger that I see is that, and I've seen this in medicine, is that people are looking to these machines to somehow be more objective or fair or even like omniscient than the humans involved. And I think that there's a very clear danger of trying to outsource the moral decision-making and judgment powers of humans to these things, rather than viewing them as supplemental tools and helpers that should be ultimately subject to the decision-making power of humans. And
exactly. Very much in agreement with what you just said.
And I think that, very clearly, part of the reason why I think that this is the case is that these machines need a very clear output, a very clear objective or a outcome that they are judging themselves as trying to achieve. Like, the reason why we can train an AI to be really good at chess or Go is that we can have it play itself. Because the outcome of a chess game or of a Go game is perfectly clear and unambiguous and virtually simulatable in a way. Like, I can play chess with you where you and I have a chessboard and we have physical pieces in front of us and we move around hunks of wood on a piece of wood with black and white squares, and there's a physical chess game. But you can make a perfectly virtual chess game that leaves out none of the resolution of a real life chess game, because all the pieces can have digital symbols to them and digital movements, and then there is a 0 or 1 that comes out. Did the machine win, or did this other machine win? Whereas the human world, and especially the complex medical world, like, I bet I could get you to admit that even the definition of a heart attack is a little blurry.
Totally.
Right. It's not exactly 0, this patient had a heart attack, 1, this patient had a heart attack. There are edge cases. There are complicating factors. It's like, well, you kind of had a heart attack, but it was also mixed with this situation that is hard to just turn into 0s or 1s, because when that EKG machine is trying to say heart attack, not heart attack, it's actually a little bit more complicated than that, because it's not just a chess game. And so, because these machines need feedback that they're trying to optimize, it is that determination of turning a real world situation into a 0 or a 1, or a score from a 0 to 100 that these machines need. And a lot of resolution is lost in that digitization of the description of what happened in the real world. Whereas in a chess game, no resolution is lost from digitizing the chess game. Whereas in the medical world, lots of real world complexity, messiness, edge cases, well, it's a little bit like this, a little bit like this, is lost when we try and digitize it. And then when we give these machines huge power, when they're acting on a simplification and a biased underrepresentation of the real world messiness, and then we say, oh, please be objective and tell me what to do, they can't really do that. And that's something that I fear, is that we're going to over attribute to them rationality, reason, whatever, when in reality they're acting at a highly compressed, highly simplified, and there's a lot of ignorance that's going on in that.
Totally. I think that you're absolutely right about that. The way I would frame that is with John Vervaeke's own comment about the alignment problem.
Yeah.
Ultimately, the whole thing boils down to the alignment problem. But the alignment problem is the existential problem of humanity writ large. And that's not really solely focused or has anything really specifically or essentially to do with technology. If we're going, and the alignment problem, just to review that, is to take our capabilities, our capacities, our competencies, our power, and align that with the good. And of course, that raises all the problems that have been struggled with from the beginning of humanity and the whole history of philosophy and religious thought, and the efforts of humans to create communities, and the failures of humans in the process of doing that. And you have all the problems of identifying, well, who are we? Is there one we? Are we unified community, or are we diverse and splintered? And if that's true, how do we deal with that? And what are our powers, and how much power do we really have? And how do we judge our competencies? And what is the good? These are obviously, kind of age-old questions, and they are the existential situation of humanity. And that's really what we are struggling with. That's ultimately what we're struggling with. And we do that in medicine. If you think about that patient with the heart attack, that's an institution, a community that, as I already said, extends across the world today, but also extends back in time. And it's guided by a principle, a guide that I would characterize as a higher principle of caring for the patient, which includes both compassion and healing. In other words, we're trying to create good outcomes for people. We're trying to make them healthy. We're trying to do things that make them better. But we're also realizing that we're not going to solve the problem of death, at least today. And therefore, we need to care for people. We need to be compassionate. We need to address their pain and suffering as well, independent of our effort to ultimately fix them. And that would be, that's embedded in the institution of medicine. Now, there's a competing and less honorable values that are running around there, like the profit motive and self-interest and achievements of, individual honor and status. And these are all in there. And we realize that, and we fail at that regularly, but it isn't really the technology that is going to either solve that ultimate problem.
Right.
And we need to keep our focus on building these communities that ultimately point to those higher goals.
Yeah, I completely agree. And I think one thing that you can kind of see in the history of medicine in America over the last 100 years is that 100 years ago, almost all hospitals were religious. And I mean that like explicitly, as in they were run by a religious denomination.
Well, I work for one that has a state as its
right.
As its name within
right.
its name.
And so they were founded by a religious denomination, often as a charity, and they were often completely unprofitable, that they took outside funding from this religious organization to keep them afloat. And that was viewed as some sort of act of mercy. And then kind of over the course of the 20th century, we started trusting more and more in academic institutions to be the source of medical wisdom as opposed to religious organizations, and having the brand name of your hospital be such and such university instead of such and such saint might have been a little bit more popular or prestigious. And now I see something like we're moving more towards corporate brands. And like a hospital that I used to work for used to have university in its name. And then this year it rebranded itself as corporate, market research buzzword X.
or just acronyms, HCM.
Right. And that they're now viewed, they might still technically be not for profit, in the eyes of the government, but they also kind of view themselves as needing to make money and stuff like that. And you see this moral progression from religious to academic to corporate. And I think that part of what we're struggling with in terms of achieving that more iconic vision of healthcare that you're talking about is that we're having sort of a breakdown in moral consensus. at the level of what is health, how should we live well, how should we die well, what's the balance between, care and honor and dignity and all those sorts of things. And healthcare is really, at the end of the day, requires sort of a philosophical, moral, or religious vision to hold that all together. And as we're breaking down in sort of consensus on those questions in our society, we're kind of hoping that technology might come along and provide the answers for us. And I think that that's going to be a huge mistake.
Totally. That was very well said, and I think I agree with that entirely. And how we start anew in creating these communities, these institutions, these larger bureaucracies of human beings working together. How do we do that now when we previously relied on these other kinds of structures and language of particularly Christian language? How do we do that now? And I kind of see that because we're kind of post-Christian in our starting point now. And I kind of see that in this whole business of how these large language models are being looked at now, because they're doing something really stupid, and then they're surprised when the stupid thing they're doing turns out to have these problems,
stupid consequences. Yeah.
And it's like, so the one that I like is the one that you talked to John about with the the Google image thing, generating thing. It's like this. If you go to a high school graduation, and in a large public high school, so you're going to have 15,000 people, maybe more than that, in an auditorium, and you got up to the mic and you asked that crowd any question. Just think up any question you want to ask it, and then you were deciding that what you were going to do is somehow integrate the entire room's responses into some sort of distilled statement. What do you think you would get? Well, you'd get a mess. Okay.
A mess. Yeah. Or at best, the mediocre average of everyone's
thoughts. That's right. It would be completely ridiculous. And not only that, you don't do that. That is not how you ask and answer questions. You focus on a domain and you curate the information from which you derive your answer. And in one way, I kind of been running around in my head in this arena to kind of flesh out for myself is a concept that community through history is actually one of its central functions is the curation of information. It goes to this notion that John talks about with relevance realization. And you hear that with Paul Vanderklay. When he talked about the large language model, he made a very brief comment about it in one of his videos where he said, well, I go to BioLogos. I think that was his preferred source of information, or one of his preferred sources of information. You can imagine applying a large language model solely to the information in that domain.
Yeah.
And it would be just as reliable as it was when he looked at it on a screen and he searched through it the way he's doing now. And it turned it into an essay, or it turned it into a speech that was then delivered by an animated pastor. If you knew that that's where the source of the information came from, and this is how these language models are going to be used, then you would be just as confident in the information that came out of that as you used to be if you were just reading it on a web page. So you have to take the responsibility of the curation into account. And that's going to be difficult because some people are going to want to listen to the New York Times and other people are going to want to listen to the Washington Post, and people want to go to Evergreen University or they want to go to Hillsdale, and that's the way culture is. And so you can get confused answers if you open your field of view too wide, and there's competing values out there. This is our human dilemma. I don't know how you think about that, but
yeah. And this is where I always like talking about purpose, because when we think that we need these large language models to be, or like Google's image generator, we want it to be accurate. But that's not exactly right. We want it to do what I want it to do according to the purpose that I'm doing. Right. So if I ask Google Gemini to generate a picture of the Vikings for me, how am I wanting to use this picture? Am I wanting to use it as a thumbnail for a YouTube video in which I talked about the history of the Vikings? Am I wanting to make a meme? Am I wanting to put this on a birthday card for my child's Viking themed birthday party? Like the purpose that I have for this thing, it should shape what it does. If it gives me a completely anachronistically diverse cast of Vikings and I'm making a YouTube video about the history of the Vikings, well, that's not what I want. But if I'm inviting my daughter's friends to a Viking themed birthday party and there's a Black Viking, an Asian Viking, a Hispanic Viking, that might not be so bad. And it sort of is like, it depends on the purpose. And I think that we think that kind of machine level objectivity is above purpose. But really, I think that the machine functionality and intelligence is beneath purpose. And purpose is also intimately connected with value and morality at like the absolute highest level. And I think that we can subject morality to just rationality and intelligence, whereas I think that we have our hierarchy inverted on that question.
Yeah, and the project that Gemini was trying to do there was just was fated to fail. We do experience some influence of these systems on us. If you just remember back your own experience with, let's say, Facebook at the beginning and how Facebook is now, or just Google search in the beginning and Google search now. I mean, Google search, at one point along the way, just a year or two after I started using it, I was like, wow, this is amazing. And now when I search for anything, I get a long list of products that I'm supposed to look at. And so it's not quite as good as it was before because of that. And it's generated its own purpose. That is to say, the commercial use of it has kind of pushed itself forward. That's kind of expected and understood. And now if you want to do what you want to do with that kind of a system, you're going to have to go to some focused domain where the inputs are understood. And that's the evolutionary trail we're on here. And I don't think it's perfect because there's going to be misuse of all this, but it's also maybe what we would have expected. And we have to kind of just understand our role, and then we get who is us, but our role in managing this. And that's my ultimate take on the whole thing.
Right. And when something's sort of a member of our community, whether it's a human or a machine, we understand if it's serving a purpose and integrated into that, then it gets given the resources it needs to best accomplish that purpose. Like Google search becoming more and more ad laden and less information first is because it needs to feed itself, basically, and feed its shareholders and stuff like that.
So there's a bit of a concern that I do think John expresses, that these things, have a life of their own to some degree. They take over. Just like in a way the Sorcerer's Apprentice model that I was talking about illustrates. Oh, it's still there. Illustrates, but it's a question of where that balance is and what are we really talking about. And I'm interested to see how John takes this forward and how it's gonna see itself in terms of his analysis of it and understanding of it as we go forward. But there's always the garbage in, garbage out, which is not a new concept, and that's going to probably be an issue for us all along.
Yeah. And that AI models in healthcare or something like that, they'll need to pay for themselves too. And if you can imagine, if the hospital is either building it itself or outsourcing it to some sort of third model modeling company, it'll want it to be accomplishing the medical purpose that it is designed for as best as it can in order to, and then the hospital will be paying some amount of money for that. But, if medicine is weird because there are, for the most part, I still don't think hospitals really operate on a profit first mindset. Some parts of them do, but for the most part, departments have budgets, and then the budgets are used kind of to try and make things as good as they can. And there's this weird balance of profit motive and maybe altruistic motive and prestige motive at work in hospitals that I think is still, for the most part, pretty healthy. Although I worry about that over the long term. But I don't know. What do you think of that?
I think that's a forever kind of a problem, but it's definitely still a problem. Mm-hmm. And there's no solution to that problem. There's only management of that problem. And mm-hmm. so again, I go back to this. It's the community and the health of the community that is the only bulwark against it, because there has to be, and this is an ongoing conversation with me and my colleagues in our system and in the broader healthcare world, that there is always a tendency to move in that direction, to maximize profit, either for the individual who's practicing or the system. And it does move in that direction more than we want it to at times. And that it needs a check. And the check on that there's only one check on it. And that is the higher aspirations of the individuals involved added together to be a community that in the end represents a resistance to that, not overcoming of it. And then you have a debate. Maybe you even have failures that are needing to be disciplined. And here I'm meaning that in the harshest terms, potentially. And those failures have consequences. People are harmed by those failures. And that's the seriousness of it. It's not only in medicine where that's an issue. You have those kinds of problems in, let's say, Boeing, panels that blow off in midair. These are real things that humans always deal with, and the only solution in the end is the health of the community as a whole, in being able to, forward, keep central the higher aspiration.
Yeah, and it's difficult now when sort of our communities are how big can a community be when it can healthily operate on these things? Because I think I was listening to Joe Rogan talk to Abigail Shrier recently, and they're talking about how on social media, there are these girls who are calling their antidepressant medication hot girl pills or something like that. And I trust the organic nature of that term absolutely 0%. I am sure that there was some astroturfing social media plan from whatever pharmaceutical company sells this SSRI or whatever it is to try and, artificially amplify the, calling these hot girl pills and pain influencers. And then, other girls start thinking, oh, well, maybe I'm depressed and maybe I need my hot girl pills, and that's spreading on social media, etc. So communities are dealing with these gigantic forces that are really big. And at some level, we could handle that at the level of, say, the US government, where we could maybe try and crack down on that sort of thing. But that means there's over 300 million of us, and we have to, vote and get our politicians to do that at a federal level. And that's a very hard thing to coordinate, and easy to get distracted or have those same pharmaceutical companies try and, give donations to the politicians or, whatever. The problem is that healthcare operates at these gigantic forces, at the level of these gigantic, huge companies and forces and stuff like that. And I'm not just trying to pick on pharmaceutical companies, but it's hard for a community. It's hard for a community to be able to make these sorts of actions when the forces are this large.
Absolutely. And the problem, of course, is exactly what you're talking about, is that along the way, there are casualties. Along the way, people are harmed. And the opiate crisis is still ongoing. And that's a very clear example of that. And it's like, what are we going to do about that? I mean, are we going to drive off a cliff? I guess that we're probably not going to drive off a cliff. But the only possible mitigation to that is, constant vigilance. And the mitigation doesn't stop the casualties. The mitigation doesn't create utopia. And so then we recognize our ultimate frailty, and we keep soldiering on. And I don't know, there's where I can be pessimistic about this, because you're absolutely right. There are forces out there that appear very difficult to counter, and it's only in the vigilance and the conversation and the pointing out of it, and the maybe some hope in open society with press to vent these things. It's clear that there are dark forces.
Yeah,
no doubt about that.
Yeah, and that's where the sort of egregore conversation about these things starts to come back in. Not that whatever AI decision makers in healthcare are themselves the embodiment of a spiritual higher order being, but they will be subject to and have the potential to be abused by those sort of higher level forces in the same sorts of ways. And it's hard for communities that are at a size that is capable of being healthy to be able to also be big enough to fight those really big forces in our current world, I feel like. And that's a pattern that we see over and over again.
Yeah.
Any
other thoughts? You want to have any other thoughts or move to a different community? What is the effect of all of this on church life or anything like that? No.
Sure. I'll pass it back over to you. Any sort of closing thoughts? I should get going relatively soon, but I'll let you sort of close this out.
Well, yeah, I would just say I think I was able to cover most of the ideas that are important to me in this area. I do think this idea of curation is now kind of more forefront for me, and I'm going to be thinking about that a little more, because I think ultimately one way to see our communities is that they're curating machines, and that the health of that is kind of what we would, I think, point to as a healthy culture is one that can curate information in the optimal way. But otherwise, I really think I've kind of run the gamut here, and I would be interested to see what John thought about these thoughts, because to some degree he speaks in such a complicated way. He's so precise and academic about the way he uses vocabulary that I don't know that a lot of what I've said or what we have said together is counter to what he would argue for. But I would be interested in his response to this concern that you and I both, I think, have expressed of the over-attribution of agency to these systems, and what he would, how he would respond to that. But anyway, I really appreciate the opportunity to talk, and I value kind of talking to you in terms of this, because we have this connection. But I've also loved your channel, even to the Church Fathers analysis, and all that has been very fruitful for me. And just if we wanted to think about a future conversation when I get my computer fixed, a future conversation, I do have ideas in the domain of your thoughts about evolution that we might have fun talking about as well.
Yeah.
But I would just thank you for entertaining this.
Sure. No, I would love to have an evolution talk. That's also one of my favorite subjects, as you can probably tell. But to kind of, I guess, summarize some things, I think that I really mostly agree with your analysis that there are a lot of positive uses that I can imagine for AI, machine learning, complex computation to supplement medicine and to grow a suite of new and helpful tools that enrich our ability to do helpful things. I think that the risk is not that these things will become, super intelligent, powerful, evil agents of themselves that have malevolent motivations or goals. I think a much more clear and present short-term risk that I can imagine is people trying to abdicate their own moral responsibility and try and give that moral responsibility to these machines that aren't up to the task and aren't capable of that. And that really we do need healthy communities that are shaped by a shared moral and positive vision that can answer these questions about how to use these tools wisely and integrate them into our health practices and areas beyond healthcare as well. I think that that's right. I just worry that our communities are too weak to deal with some of these super large forces that are at work in the world, and that'll be a battle, but I suppose it's always been that way.
There you go, Sam. This is one of the things I love about you. You're very good at that kind of articulate, clear language, and I really value that in you, and I agree with you entirely. That's exactly my take on this as well.
All right, sounds good. And I look forward to having a future conversation with you about evolution and things related to that.
Very good. Thanks a lot.